Subtopic number 2, which is on resultant magnetic field produced by current carrying conductor. So in this subtopic, you have to be able to sketch and determine resultant magnetic field diagram at a point, determine the direction of magnetic field using right-hand rule, determine the magnitude of magnetic field by using all this equation here for different type of conductors. Okay, so that is basically the learning outcomes. So when the current flows in the conductor wire, the magnetic field will be produced in the surrounding place, as can be seen here. So magnetic field ni adalah a vector quantity with the SI unit of Tesla ataupun satu lagi Weber per meter square. Okay, the direction of this magnetic field can be determined using right-hand grip rule, as can be seen here. Okay, so generally there are three types of them, which is long straight wire, circular coil, and a solenoid. Untuk long straight wire, this is the equation that you will be using, where mu naught is the permeability of free space lah. Okay. Alright, so let's try and look at the direction given by the right hand grip rule for long straight wire. So when the current is pointing upwards, our thumb will be pointing upwards and the other fingers is telling us the direction of the magnetic field. So this is anti-clockwise punya direction. So basically, if the current is pointing upwards, the magnetic field will be anti-clockwise lah. Tapi bila they're pointing inwards, which is into the page, your thumb is pointing downwards, the other fingers are telling us that the direction of magnetic field is basically clockwise. Okay. Right, so untuk circular coil pula, this is the equation, and then this is the circular coil punya magnetic field. The direction is also given by the right hand grip rule, where the thumb is telling us the current and the magnetic field is determined by the direction of magnetic field is determined by the other fingers. Okay. Untuk solenoid pula, this is the equation. So there are two of them. One is for the center and one is for the end lah. So the small n is the number of turns per unit length, whereas the capital N is the number of coils. Okay. Okay, untuk solenoid pula, untuk right hand grip rule, the thumb is telling us the north pole lah. It is the north pole, and then untuk the other fingers is the direction of the current. Okay. That is current. How about magnetic field? So untuk magnetic field pula, kamu akan buat the same thing as well lah. Oh, I think I didn't add that to this year's notes. Let me just double check with my previous notes. This is my previous notes. This is solenoid. Okay, so basically this is the magnetic field for a solenoid lah. Okay, I think I'm gonna add this if I rajin lah. I'm just gonna add this later. So basically it's the same thing juga. Kamu akan guna right hand grip rule, where your thumb is the direction of current and then your other fingers is the direction of magnetic field lah. See, sama juga kalau the current is into the page, the magnetic field will be clockwise, whereas if it is going out of the page, it will be anti-clockwise. Okay. Alright, so that is for the solenoid. I have to add this somewhere here. I guess I'll remove this later. Okay, I'm gonna remove this and then yeah, I'll do that later. Okay, so example number 1, there are two long straight wires placed parallel to each other and carrying the same current. So this is the wire, and then we have to draw the magnetic field lines pattern around both wires when the currents are in the same direction. Okay, so this is the current. Okay, I'm gonna draw it with green color lah. Okay, so magnetic field lines. Something like this lah. Okay. Right, tapos so kita draw for this one as well. Okay, begitu. Right, so this is, since it is pointing upwards, this is gonna be anti-clockwise lah. Right, so this should also be the same. Okay, so that is the magnetic field lines. For the one that is at the opposite direction, I'm just gonna copy this. Okay, alright, let me just do it again. Copy, paste. Okay, so now dia satu lagi tu opposite direction. Okay, so sekarang ni macam ni sekarang. For opposite direction, ingat dia akan jadi clockwise lah. I'm just gonna draw it. Okay, clockwise. Kalau kamu, tapi lah hafal, you just have to apply right hand grip rule je, okay? So you just use right hand grip rule to determine the direction of magnetic field, okay? Alright, so basically this is the magnetic field direction. Right, example number 2, we have a long wire carrying a current of 50 ampere placed parallel to 2 and 5 centimeter away. Let me just draw the wire. So we have 2 wires here, and then they are placed 5 centimeter away from each other. So this is 5 centimeter, this is wire X, this is wire Y. So now we have to determine the magnitude and direction of the magnetic flux density at the point midway between the wires. So at this point here lah. So we have to determine the current when the currents are in the same direction and when they are in opposite direction. Okay, so this is in the same direction. And then do the same thing, but it is in the opposite direction lah. Okay, so I guess I have to can't really just gonna do like that lah. Okay, so in the opposite direction macam tu. Okay, so this is your current. Right, so IX, IY, IX, IY. Okay, so let's firstly determine the magnitude dulu lah. Okay, so BX is mu naught IX 2 pi RX. So yang ini kamu akan dapat 4 times 10 to the power of negative 4 Tesla. And then you have to calculate for BY juga. So basically the magnitude ni akan just stay the same ah. The direction sahaja yang berbeza. So this is going to be 8 times 10 negative 5 Tesla. Okay, so the magnitude ni akan jadi constant. Okay, so the first situation, this is the second situation. Oh sorry, not this one is I pula. This is I. Okay, so for I. So sekarang ni kita punya magnetic field ni dia akan jadi macam ni. Okay, so they are anti-clockwise kan dua-dua. So yang ini pula anti-clockwise tapi dia pointing downwards at that point. Okay, so sekarang ni kita fokus satu point je. At this point saja. So kita tengok arrow di sini ni. Okay. So bila kita tengok dia secara okay, so sekarang ni kita lukis dia macam ni ya. Okay. Wait, let me just double think first. Let me just think. How can I draw this so that I can explain to you? Okay, I'm just gonna Okay, so sekarang ni ini kita punya conductor. I guess I'm just gonna draw it. Okay, ini kita punya conductor. Okay, so sekarang ni kita just mau focus at this one point here. So kalau kita tengok at this magnetic field for this side, okay, magnetic field for this side is gonna be going into the page. So kita akan nampak X. Untuk di sini pula at this point here kita akan nampak wait I'm trying to imagine it first. Okay, yeah. Lepas tu di sini kamu akan nampak dot. Okay, so maksudnya salah satu di sini ni dia akan jadi dot, salah satu lagi jadi X. So apa yang berlaku at this point here is one of it is gonna point upwards, one of it is gonna point downwards. So if we look at it this way, so our eye will be di sini kita akan nampak the one that is gonna point downward is BX. The one that is gonna be pointing upwards is BY. Macam itulah. Okay. So sekarang ni the resultant is just BX plus BY. Tapi kita perlu tahu direction dia. Negatif kah positif? So sekarang ni since BX is going Let me just think. Sorry. Yeah, so since bx is going into the page, it will be positive, okay? So into the page will be positive. Bx is into the page. Kenapa dia into the page? Sebab sekarang ni kita nampak dia punya x, okay? By pula dia akan go out of the page. Kenapa dia out of the page? Sebab sekarang ni kita nampak dia punya dot, arrow tu dot, okay? So untuk bx, untuk bila kita nampak x, dia akan jadi positive, okay? Tapi bila kita nampak dot, dia akan jadi negative. So that is the sign convention lah. So bx is positive tambah dengan by yang negative. So you will get the, oh, I didn't calculate it. So I have to calculate it now. Sorry everybody. So you will get 3.2 times 10 to the power of negative 4 Tesla as the answer. Okay. Lepas tu apa lagi? Lepas tu kita buat untuk yang opposite direction. So untuk opposite direction, bx plus by, kita perlu tengok juga. At this point, apa yang kita nampak is, this one is gonna be, tu lebih. Oh, cannot intersect each other, the line. This is so hard to draw perfectly. Not hard, it's just, I'm lazy. So this is anti-clockwise. So I'm just going to focus at this point here. And then this one is clockwise. So this is going to be pointing upwards. Okay, so at this point here, apa yang berlaku is both of them is going to go into the page. So kalau into the page, apa yang kita nampak? Kita nampak x, so it's going to be downwards. So bx, by is all downwards. Okay, so this one is gonna be both positive sebab dia go into the page lah. So 4 negative 4 tambah dengan 8 times 10 negative 5. So kamu akan dapat, my god, I didn't calculate it again. Tambah aja. Okay, tambah, so kamu akan dapat 4.8 times 10 to the power of negative 4 Tesla. Alright. Lepas tu question B. When the current are in the same direction, there is a point somewhere between x and y at which the magnetic flux density is 0. Okay. So sekarang ni, dia consider about same direction punya lah. Okay, dia cakap ada satu distance dari wire x ni. Dia punya distance ni, dia punya magnetic field, the resultant magnetic field will be equal to 0. So kita perlu carilah this distance here from wire x. So ini apa pula? Wire yang, this is rx lah basically, this is ry. So rx is gonna be r. So ry tu apa pula? We know that this is equal to 5 cm. So ry is gonna be equal to 5 minus r. Okay, so this is the value of ry, equation for ry. So sekarang ni, since we know that the resultant magnetic field will be equal to 0, we can let bx to be equal to by lah. So this is mu naught ix 2 pi rx equal to mu naught iy 2 pi ry. Okay, so sekarang ni kita boleh cancel apa yang boleh cancel. It's just this one lah. So we are left with ix, rx is r, iy 5 minus, no, not 5, 0.05 minus r. Okay, so susun lah semua ni bagus-bagus. And then you should get something like this. I can't do that. Okay, so bila kamu rearrange for r, kamu akan dapat 0.05 ix over iy plus ix. Okay, so kamu akan dapat, you will get 0.0417 centi. 0.0417 meter. Okay. Alright, so that is the solution for example number 2, and that is basically subtopic number 2.